Here are the parts required to build the badge, and here's a front view and a rear view of the circuit board. There are very few parts on this. It's such a minimal design, but yet it's capable of 32K of RAM and about that same amount of ROM, and it doesn't really have any I/O on it other than a 7-segment display, but it also has a TTL level serial port for communication with a PC. To show how minimal this circuit is, here's a schematic. You've got your 6502, it's actually a CMOS, so a 65CO2. It doesn't have a crystal, it has a ceramic resonator. Has a sort of a versatile reset circuit involving power up and reset from other sources. It has the serial RX or RXD signal coming in as an interrupt through a resistor, and it's all handled in software. Here's the serial adapter, which allows the badge to be powered from 5 volts or VCC pin on what's sort of a standard Arduino type serial port connector, which also includes 3.3 volts, 5 volts VCC, TXD, RXD, and ground. Only the RX and TX are really used on here. There's a RAM chip which can be anywhere between, I think, about 2K and 32K. I have 32K installed on mine. There's an address decoder which consists of a single 2-input binary, 4-output decoder chip. And then there's the ROM, which can be anywhere between 2K and 32K. Actually, I got that wrong. This is the EPROM up here. It's 8K to 32K. And then the RAM is anywhere between 2K and 32K. There are 2 additional chips, which are just latches holding in the combination of address and data lines, which are used for the matrix scanning of the LED display. And I believe that it's mapped out so that if you read from the ROM memory location, you get the contents of the ROM. If you read to certain locations within that same section of mapped memory, then it drives the display. The TX line comes out of an otherwise unused pin of one of the 2 latches, and it's just running through a resistor going to the TX line of the serial port. And then there's a option for a battery or a rechargeable battery, power switch, and depending how you build it and which components you install, it can be set to run with a rechargeable battery or not. And that's really about it. There are 4 shunt jumpers which can be used to configure the type and size of RAM and ROM chips that are installed. And there's really no other hardware to it. Here are the IC sockets used. There's only the 6502, the 2 address and data latches, and then the one chip that has a dual 2 to 4 decoder for use with the reset circuit and the memory addressing, and everything else is done with just a handful of discrete components. But you'll notice here that there is one chip that's soldered directly to the board without a socket, and that's the 32K RAM chip. To fit on the board, it has to be stacked with the EPROM, and the EPROM's in a socket, and the 32K RAM chip just sits directly on the board in between the 2 rows of pins of the EPROM socket. The LED display is, I think it's almost a surplus part made by Roan. It's a 7-digit, 7-segment display that also includes 7 discrete LEDs both yellow, red, and green colors along the top of the display. And two of those are actually used as virtual Zener diodes in the circuit, and the rest are used just sort of nonsensically to run like a Knight Rider strobe that just goes back and forth as the monitor program is running. Just something to do with those extra LEDs. As recommended by the producers of the kit, there is no filtering on the display, but I always hate the way LEDs look without filtering, so I put my own red filter on this display. There are 4 shunt jumper positions on the circuit board, which are allowing the builder of the kit to configure the RAM and ROM for different sizes and types of IC that could be put on here. It's fairly flexible in that regard. I could have actually used just fixed jumpers on mine, but I decided to go and put the shunt jumpers on anyway. It was kind of a race for the developers to get this ready in time for the Vintage Computer Festival. And about a week before the festival, I received the EPROM from the person who was doing the software development, the monitor program, the basic, the assembler, the various utilities that are all bundled into this EPROM. I think it's a 16K EPROM in this case. So that's installed here on top of the RAM chip. The badge is powered by a set of 3 AAA cells, which will run it for quite a long time and will back up the memory for years. Most of the power is used by the LEDs. I don't think there's any backup for the RAM if the batteries are removed. Besides being a scrolling name badge, this badge is also a fully functioning 6502 microcomputer, although without any other I/O, such as a keyboard or a display that can do something besides name badge functionality. It needs to be connected to a terminal, and to that end, I acquired a USB to RS-232 adapter cable, as shown here, and also a RS-232 to TTL serial adapter circuit board. I think there's about $20 between the two parts. And then I used a free terminal emulator program called TerraTerm that I also use on my Altair computer. There are tons of similar programs out there. This is just the one that I use. Alright, here's my first test of the 6502 badge in its communication with a computer and setting it up to display a message of my choice. There's the TTL level serial port, and I have a Sabrent or Sabrent brand USB to RS-232 adapter cable, and that in turn is plugged into a generic RS-232 to TTL level serial adapter board, which uses the MAX 232 or similar IC, very common type for this purpose. And it is in turn cabled over this homemade gray wire, which has 3 conductors in it, and that brings over the ground, the TX and the RX signals at, again, TTL level serial, and comes to this plug, which I can plug into the serial connector on the badge. The TTL adapter requires a power supply of the same voltage as the signal you want, and since I want TTL level, which is 5 volts, I need to give it a 5 volt power supply. There is a couple of pins on the circuit board which I will use a plug and a proper regulated power supply little wall wart to power that eventually. But just for this test, I have a couple of test leads going over to a hastily rigged up set of 3 AAA cells, which gives me 4.5 volts, which I suspect will be close enough to the 5 volts to work with the badge. And over here I've got my Terraterm software running, and if I turn on the badge, I've removed the power-up reset circuit on it, but it does power up anyway, sort of randomly, and if it doesn't, I've got a reset button on the back that'll make it boot up. But right now it's reading its default message of 6502 badge for, well, it says UCF, but it's supposed to be VCF, Vintage Computer Festival. This is the 40th anniversary of the use of the 6502 in the Apple II and the Commodore PET and Atari products. So it's sort of a commemorative badge. But anyway, if I take the cable here and make sure I know which side is ground and plug it in, it continues to work, but it should be able to communicate now. If I go here and type enter, I get a dump. If I type in, let's see, 0000.00FF, it gives me a dump of that address range in hexadecimal. So that's working. And the only time that it's, let me do that again. Oops. And now I'm going to watch what happens here when I do it. It goes away while it's processing, then it goes back to scrolling the message. So, according to the manual, if I want to set the LED text, I just type the S command followed by up to 32 text characters. So if I go here and type in S Paul, now it reads Paul. How about that? And it's expecting to display up to 32 characters, so the unused characters take the time it would normally take to display them before it comes around and does Paul again. The camera makes it look like some digits are dimmer than others, but they're all equally bright. So that worked pretty well. It's kind of amazing. The monitor program allows dumping an address range, changing data bytes, executing a program at a specific location, moving a range of memory from one place to another, doing a list of program lines in BASIC, doing a disassembly of a range of memory, text dumps, all sorts of things. There's the set scrolling text command, upload a file from the PC to the I guess to the badge, download a file. I can type in V for monitor version, 65CO2 monitor version 5.2 with EH basic version by Lee Davison. And if I want to get into BASIC, I can enter an assembler. I can cold start into EH BASIC or warm start into EH BASIC. What if I do a pound sign here? So is it in BASIC? Print commands. Oh, it just did a list there. Well, I didn't know what to do with that. It's not in BASIC. Maybe I can type a @ symbol. Ah, now it's in BASIC. I'll say 32K. What happens? Memory size doesn't like that. Ah, I just hit enter. It's got 32 bytes. So I can go 10 for I equals 1 to 10, 20, print I, 30, next I, list. I didn't know that. Well, I guess I'm not using the right syntax. So I'm going to type in S and then it doesn't really like doing the letter M, does it? In 7 segments, turns it into some weird thing. Maybe I should just make it an N. Let me try it again. It works. It lives. Let's try getting into BASIC again. So I should be able to do the warm start of BASIC now that I've done the cold start once. Yeah, so let's just try printing 1 plus 2. It didn't like that. Print 1 plus 2. Didn't like that. Print 1 plus 2. Maybe it needs to be in capitals. Ah, needs to be in capitals. So let's try this. For I equals 1 to 10, list. Ah, okay, now we're getting somewhere. I Wonderful. Alright. Anyway, so now I'm going to pull the plug and it'll continue to read the message without being hooked up to the personal computer. If I turn it off and back on, it resumes doing it, so all is well. And here's the setup with my proper power supply. It's a 5-volt regulated wall wart. I've got a barrel connector plugged into it, and that goes through a short cable and plugs into the power terminals of the TTL adapter board. So it's a much cleaner setup than I had before with those batteries and test cables. And as can be seen over here, it is working. I can do version again and it is communicating.